So I'm just going to finalise the last presentation for today, so hopefully you can all stay awake for this one. We've got the last another two trials in the forage space that are also running at the moment, and I'm just going to go through each of those separately. So the first one we're looking at is assessing the processing methods and ensiling time to increase the nutritive value of our sorghum silage crops. So as a bit of background, we know that sorghum grain and forage crops play a key role in our dairy feeding systems across Northern Australia. And one of the things that we've found, particularly in the last 10 years, about white sorghum silage being quite a comparable crop to corn. So from a feed analysis perspective, on paper, these both white sorghum silage and corn silage can look very similar, okay? But there's two things that probably are a little bit lower, and that's from a starch digestibility perspective, and that's due to the structure of the sorghum grain, but also the size of the sorghum grain, which has been spoken about already a bit today. And that's because also partly that processors are unable to crush each and every grain. The other thing is about NDF or fibre, where whilst it can be relative on paper to corn, we don't see the digestibility, the digestibility is reduced in comparison. But one interesting thing is that we continually get high intakes of sorghum silage. So even if we look at a diet on paper and we formulate it for that cow to be eating 22 kilos of dry matter, in a sorghum forage-based diet, sometimes these cows are eating up to 25 kilos. So is that a function of chop length? Or, you know, obviously it's not sitting in the rumen as long as we would think it would be for something that has a lower fibre digestibility. So how can we improve both starch and fibre digestibility? So one of the key things we wanted to look at was from a processing point of view. Okay, so effective processing is the key, and that's one of the things that have been talked about a lot today. From a starch perspective, we can tighten those rollers that crush the grain. Okay, standard factory setting is around 2 mil. It's quite small really when you've got all that forage going through. And good operators actually tighten those rollers to 1 mil when they're harvesting sorghum grain silage. We can also extend ensiling time, and Jordan touched on that as well. And that's quite interesting because as long as we break that grain, we allow over time the silage acids to break that down and potentially improve starch, the access of starch from the rumen. And from an NDF perspective, we can look at chop length. Did you know that even in recent times, when I had a look at all the literature, that we couldn't actually find anything on sorghum forage as a silage and what chop length to chop it at. So there's no literature published on that I could find anywhere. So we're basing this all on corn silage chop lengths. And then there's adjusting differential speed as well. Okay, so I don't know if you've heard about shredlage, but that's one thing where shredlage is set at a 50% differential speed, so we're causing a bit more of a shredding effect on the forage. So the objective of this study was to look at starch and NDF digestibility of 3 popular sorghum species, and to assess the effect of processor settings, so chop length and differential speed, and also to assess that over ensiling time, so a 6 and a 12-month period. So the varieties we chose were popular varieties that are used across the dairy industry, Graze and Soul being one, and Liberty is a white grain sorghum and Sentinel is a red grain sorghum. We have planted all those in quite a large area, and we're looking to chop them at 12, 16 and 20 mils, and at 2 different differential speeds. So 30% being the factory standard is what those processors come out at, and then 60%. So what is differential speed? Well, it took me a while to get my head around this because I have no mechanical brain at all, but our standard factory setting at 30% has two separate pulleys at different sizes, okay? So pulley 1 is at 200 mil, and it drives the 125 tooth roller on this specific machine. And pulley 2 is a 250 mil pulley that runs the 100 tooth roller. Okay, so they run at slightly different speeds, or a 30% different speed differential. So from a 60% speed differential, these pulleys change. So the pulley size changes somewhat. Pulley 1 is a little bit smaller at 173 mils, and pulley 2 at 270 mils. So as you can see the difference there in the table, but there's essentially 100 mil size difference between pulley 1 and pulley 2 for the standard, for the 60% speed differential. So that front pulley is much smaller. It does 60% more revolutions than the back. And because it's running faster, the forage tears through the machine more, okay? It results in that shredding effect. Yes, it uses more horsepower and it uses more fuel, but it's supposed to do a much better job. So what we did was we planted these 3 varieties in quite a large area in early December, and we didn't apply any irrigation, so it was just planted because it was good. Wasn't irrigated because it was a good season. We harvested at the milky dough stage in early March, and then we harvested and processed each variety using those defined differential speeds and chop lengths. So this is actually no small task, because we had to get the contractors to be happy to we pull them up for an entire day trying to not only do the work, but also stopping and starting, but also the changing the pulleys, which Master Chop was really, really good with their time on this one. So whilst we grew a big area, we really only needed a very small amount, but Mark was there driving that tractor trying to catch the forage as it come out. So what these silages came out like from a visual perspective. We achieved our 12, 16 and 20 mil chop. I was quite surprised how accurate it really was. When I measured it with a ruler, I was like, holy dooly, it's quite accurate. Obviously not every piece of forage is like that, but just pulling out a bit of the leaf, it was clear. And you could visually see the difference between those silages and their chop length as well. So this was a 16 mil chop length, and both of those are at differential speeds. Now, I couldn't see any difference looking at it at all, but when I started taking out little pieces of the forage, you could definitely see that the 30% speed differential was probably cleaner cut than the 60% speed differential. We've got a bit more tearing in that one. We've got, shredding, and they're sort of more cut at angles. So that same day, all those different treatments were installed in these mini silos, and there were 144 tubes, and we compacted it to what the recommended silage compaction rate is on farm, so around the 700 kilos per cubic metre, and we have now got them, they're bubbling away. Well, not really bubbling anymore, but they were for the first 4 weeks, and they'll be inside for 6 to 12 months. So we're yet to see what we get from those results, because we won't sample them till September for the 6 month, and then March again next year for 12 months. And the other trial that we have going on at the moment is about potential forages with productivity benefits for silage production. So this is a 2-year trial, and it's looking at both winter and summer varieties, and we're going to look at those over the next 2 years. So these trials will change a little bit depending on the season. And so the overall objective of that is to look at the effect of variety and management of cereals harvested as silage, and look at their dry matter yield and quality characteristics to enhance milk production and farm profitability. So from the winter trial, what can we target to improve silage quality on farm? So the first way we were looking at was variety selection, but my goodness, there is more than 200 varieties of wheat and barley on the market, and I was just like, where do I start? I don't know where a farmer starts, but as I spoke to an agronomist, he said, oh, well, we use local experience yields, and then obviously their pest and disease resistant ratings. So if you're happy to lean onto all those things, then that's probably how you choose your variety. But then I thought, well, we've done variety trials and plenty of them before. So what can we actually choose that's got an attribute that might be, relevant to silage production? So basically wheat and barley are bred for human consumption. And what do those different varieties offer? So I went through a lot of varieties and decided to look at what's the difference between a malting or brewing variety compared to a grain variety, and this is from a starch perspective, so what different starch types are within those grains to start with, and also, as we grow them, we find out how much yield we would get from a dry matter yield perspective as well. Oats I decided to put in oats because I found one that was 61% starch in the grain, and I'm like, well, not many people grow oats, but maybe we should consider it. Those varieties have been improved a lot over the years, and we probably discount it somewhat. So we've got a dual purpose variety and a grain oat variety in there. And then from a wheat perspective, there's all these different classifications, and so these varieties were based on, there's a prime hard, Australian prime hard wheat variety, which is like a white hard grain that's used for noodles and things like that, and it's got it has to have a minimum protein content of 13%. But then from the Australian soft wheat perspective, it's got to have a maximum protein content of 9%. So they're very different in how much, what nutrients they can offer from just the grain perspective itself. And then there's the durum wheat, which is quite a very hard wheat that is amber coloured and used for pastas and things like that. So what can they offer in comparison? The other thing we wanted to look at was specific growth stages that influence quality. We know from from GRDC work and many trials, but also the hyper yielding crops trial, that the application of nitrogen and fungicide at tillering is less important than it is at stem elongation. And that's when we apply these at the presence of the money leaves. Now the money leaves was a pretty cool term for me because I was like, oh, I've never heard of that before in a silage perspective, but this is the last 4 leaves that are developed and are most physiologically from that perspective more important or most important from grain fill and yield potential. So they need to be protected from disease, and also we need to make sure that nitrogen is available. So I thought this was quite complex when I first heard about it, but really you just grab your wheat plant and you feel up the stem, and if you feel like a little node or a bump in the stem, that represents stem elongation. And again, this is the critical development stage that determines grain yield and size. We also know that many farmers don't treat for leaf rust or stripe rust, especially if you're growing silage. So this is all from a silage perspective. And it's probably well known for grain farmers, but not so much from a silage perspective. And research trials have shown that barley that has leaf rust can have yield losses of up to 56%. So sometimes if you look at quality analysis of wheat or barley and see what the starch of our silages are, can be only 3%, and you're like, oh, why? When I thought I had a lot of grain in there. But maybe maybe it's part of not having enough nitrogen when the grain needs it, and also because we're not treating when we've got the presence of leaf rust, or in this case strut rust for wheat as well. So the treatments we applied was standard management, so just applying nitrogen at the beginning and no fungicides. Second one was applying nitrogen at stem elongation, and they recommend between 50 and 100 kilos of nitrogen. We just chose 50 because of how fertile our soil is at the moment. A fungicide control, and that was to apply at either growth stage 32 or 39, but in between when the plants are at stem elongation. Taking into consideration withholding periods, because we're harvesting for silage, not for grain. And then a high management, which is a combination of both fungicide control and also nitrogen application. So we've just set the trial up like this, where we've got all our varieties planted horizontally, and then vertically we've applied these treatments as needed. And I know I'm running out of time, but one really important thing as part of this trial is that we're going to understand, or try to understand, the relationship between silage yield and grain yield to define on-farm silage prices relative to grain. And why is that? Well, when farmers pay for their silage, it's usually standing in the paddock, it's based on the rule of thumb of 1/5 of the grain price. So that assumes that grain yield is 20% of the silage yield. But is that correct? I mean, is that the same for corn as it is for barley or wheat? And I think it's really important that we sort of understand if that's the case. And we've got different varieties here to look at that. So currently we applied 250 kilos, 15 kilos of urea across the paddock. We've planted all these varieties in early May. Unfortunately, we got fall armyworm even that late in the year, so we had to apply insecticide, and we reached stem elongation at 8 weeks after planting. So at that point we have applied the 108 kilos of urea per hectare. That's currently what the trial looks like. We have a little bit of lodging in the Lapurus barley, but the rest are all looking really good at the moment. And so what's next is that we will apply some fungicide when we see the need, because we're at that stage now. And we will sample for dry matter yield and quality when we reach the silage stage, so the milky dough stage, and then we're going to take that crop through to grain for grain yield and quality as well, and then work out that relationship from a cost perspective. Thanks very much.